Next up, we have Diego Mancini. He's a software engineer researcher with IBM. He's been working for more than 10 years in computer science as a software engineer and as a systems administrator. In 2014, he started working for IBM Argentina in information security on the design and implementation of the Advanced Access Content System 2 for Ultra HD Blu-ray. In 2015, he relocated to the US to be part of the information security research team at IBM's Almadown Research Center, where he's been working on blockchain, and in particular, Hyperledger Fabric, focusing on permissioned blockchain networks and identity management.
Good morning. Hi. So, well, as Jeremy mentioned, I am from IBM Argentina originally, and I relocated here 2 years ago to start working on blockchain, and particularly on permission networks. And every time I hear the word permission, this is what comes to my mind. For those that are related to computer science, this makes sense. For the rest, sorry. So, yes. And every time you look on the internet, what are the differences between a permission blockchain or a permissionless blockchain? Mostly these are the main differences you are going to find. On a permissionless blockchain, like a Bitcoin blockchain, anyone can participate. The governance is public and transparent, but that also means that it's hard to reach consensus with the community to define the direction of the technology. A permissionless blockchain provides a shared truth and logic and communications to all the participants. And it tends to be compute intensive because given that you don't know who is participating on the network, you require consensus algorithms like proof of work or proof of stake. Sorry. On the other hand, on a permission blockchain, the behavior is more like a consortium-like organization. So participants are mostly well-known. It could be also be fully private. That makes easy to comply with regulations and to govern the direction of the technology. It tends to be more performant because you don't require compute-intensive consensus protocols. Then it's less compute-intensive, as I said there. So, but those differences are the result of answering those two questions. Who can submit transactions to the blockchain network, and who is able to validate and verify transactions to create blocks and commit them to the blockchain. So on a permissionless blockchain, anyone can, and that's the reason why we need proof of work consensus protocols. On a permission one, it depends. Anyone can do it if the configuration is so that you have a great amount or every participant is part of the consensus protocol, or you can have a few participants there. So to achieve this in a permission blockchain, we will need identity management. So we need to assign identity to participants in order to determine who is who on the network, and access control mechanism to restrict who is allowed to perform which operations. But why do we need permissions? Why do we need a permission blockchain? Because, well, sometimes business are, or most of the times, business are regulated, and it's not true that anyone can do any action on the network. Sometimes you need to know the identity of the participants when two companies or more companies are interacting, mostly to determine reputation or to know who you are operating with. And because mistakes happen, sometimes human mistakes, sometimes software mistakes, and there could be a need to solve a dispute, and if the dispute cannot be solved by mediation, we need to fall back to the legal system. But the real question for me is why we need to choose one option or the other. Why cannot we support both options? Not at the same time, obviously. We should aim to have a modular blockchain implementation, and we should be able to replace components of that implementation or to fine-tune components of that implementation in order to, for instance, if we want somehow public or permissionless blockchain instance, fine-tune the identity services component to have full anonymity for the participants, not having access control, for instance, and have a proof of work like consensus protocol. Or we can go the other way, having identity services, access control, and a PBFT kind of protocol. In conclusion, I do believe that having a modular and pluggable blockchain architecture would be beneficial for everyone, because we will be able to adapt it to the use case needs, even if it is a real world business company or a consortium of companies trying to interact via blockchain, or if it is a non-profit organization that needs to protect the identity of participants. But I do believe also that identity management and access control should be embedded in the underlying architecture of this solution. It also needs to provide granular identity management to guarantee that when sometimes you want to have a full anonymity, the network is not going to violate that. And when you need to have somehow a way to identify participants, a way to being able to do it. But identity should not be controlled by a single organization, because that kind of data is really sensitive. So it should be handled by more than a single entity. And that's it. Thank you.